Right. This we discussed. Right. Before ending the session, we discussed about terminology related to the curved surfaces. Is there any confusion in this? Everyone clear? Or there any confusion in understanding the terms related to the curved surfaces? Photopic reaction. Right. So no confusion in understanding the terms related to the curved surfaces. Right. Here, now we are understanding the behavior of light rays with the curved surfaces. Now I'm discussing the topics which are given in the page number 59 in your textbook. So there is one information given at the top, right? Light ray bending towards the normal or away from the normal. So that blindly given printed information. So here practically do we experience that or not? So for this, just you need to conduct one activity, inserting the pencil into the glass of water. Do you see that pencil inserted into the water? Just to speak out. Speak out, anyone?
Yes, sir.
Right. Just keep on. Mic turn on to answer me. Here, what you feel by observing the figure? Pencil is a single or two different pencils inserted? Only one pencil or different?
One pencil.
Very good. One pencil only. But how do you feel? Is there any connection between that two parts you are observing here? You are observing two parts. Yes or no? One is inside. One is outside. Water.
Yes, sir.
Is there any connection between them?
Yes, sir.
No connection. What you observed here. But when we take it out, you can see a single one part is complete pencil here, right? But inside the water, you are observing two parts. Because of what reason? Because of what reason? Bending. Really, that pencil is bending? Really, does it happen? No. But it is due to what? Presence of water. If you insert that pencil into the empty glass, can you see these two parts? Can you see? No. Here we can see only single part. We can see only single part. So here it is due to the refraction of a light. So for understanding in which direction that is bent, this practical example I am using. So I can use here interface, that which is separating, right? So this is what interface. Okay, single only, but you are unable to see that plane surface, right? So side view, you can see single only, but I'm showing you from somewhat top. So that's why I've taken two lines here. So one interface only, plane. It is what? Plane, right? So now I am drawing the normal at above the water interface, above the interface. One is to measure below the interface. Where do you measure the angles here? Here, look at the angle is going to be measured here, upper part between the normal and the pencil. So this I am treating as now incident light ray for us. Incident light ray. So here I am measuring the angle of incidence. Angle of incidence. Then below the interface, downside to the interface, we have one more. We have one more. That is what here, that base, that edge of the pencil, now we are using as refracted light ray, right? So that is what here refracted light ray for us. So here refracted light ray making something angle with the normal here, this one. So this angle is now taken as angle of refraction. R, angle of refraction. So here now compare angle of incidence and angle of refraction. Are they equal? Are they equal? Answer me. They are not equal because that pencil is bending. That pencil is bending. So here simply that angle decreased. Angle of incidence is greater than angle of refraction. Simply the ray is bending in what direction? In what direction that light ray bends? Towards the north.
Towards the north.
Right? So this practical experience I am using to generalize if light ray propagating from rarer to the denser medium, it bends in what direction?
Towards the normal.
Towards the normal. What is its conversion? Opposite. Denser to the rarer. What you can generalize? In which direction it bends?
Away from the normal.
Away from the normal. So this you need. This point you know, easy to understand this complete chapter. Bending towards the normal, bending away from the normal. But in which case? That you need to keep in your mind. Is it clear, everyone? Is it clear? Right. So next we'll go for understanding the curved surfaces. Right. What happens if light ray propagate from rarer to the denser medium? Right. So here we have different cases. Right. So the first case is targeting the light onto the curved surface along the principal axis and along the normal. Right. So in this case, what happens? So identifying the terms related to the curved surface, what this point is, name the point on the curvature pole, right? On the curved surface, this point is what? Pole. So I am separating the mediums, right? Before the curved surface, right? Air, rarer medium, and shaded region is water, it is denser medium. Then name the point as pole here, P. Then identify its center, name as C here. Then we need principal axis. Connecting the pole and center of curvature is called as principal axis. Right? Now I am targeting the light ray onto the curved surface. Onto the curved surface. So here one is along the principal axis. Can anybody answer me? Its behavior. Its behavior. Unmute yourself. Along the principal axis. Principal axis is nothing but what? Connecting the center and the curved surface. What you can call that red line? Point of incidence is connected with the center, called as normal. Is there any confusion here? Why I called that red line connecting the center and pole? I'm not drawn line, connected segment. Right? Is there any confusion here? Why I called normal? It is normal at that point, right? So what the angle made by the incident light ray here in this case? What the angle of incidence? Angle of incidence is what? 0.
0 degrees.
In this case, angle of refraction also 0. if you instant any light ray normally, suppose into the glass of water, insert the pencil vertically, vertical to the water surface, you cannot see any bend. You can see the size difference, that is different thing. We'll discuss later. But no bending, right? No bending. So this is, we need to understand. So in case of this light ray, you cannot see anything bending. Then one more ray is taken. One more ray is taken, passing through pole. In case of this also, you cannot see any bending, right? So after reflection, they propagate in the same direction, right? Then one more I have to show here only. I'll show you that. One is here simply directed towards a center, right? The light ray instant, which is directed towards a center, right? So in this case, what happens? It is also nothing but instant normally, right? So I will show you that line. The line joining the center and the point of instance is called what? Normal. So black line is what? Normal. So what happens after entering that light ray into the denser medium? Will it bend? No. This is also a case instant normally. So it is entering into the denser medium and remains undeviate. Remains undeviate. So this is you need to understand. Is it clear, everyone? If there is any confusion. So I got 3 rays which remains undeviate. Can you name them? I got 3 rays. Totally 3 rays are there which remains undeviate. Remains undeviate. Remains undeviate. Can you name that race? I want the name. Please try. No one responding. Don't know names? I will ask you one by one. Right? Here, the first ray, I am asking you this one. How it is? How it is propagating? How it is propagating?
Through the principal axis.
Don't say through the principal axis. Along the principal axis. Right? How to use that? Along the principal axis. So this ray is along the principal axis. Then see the second ray now. This I asked you. How it will be? Anyone? Second ray.
Sir, towards pole.
No. Passing through pole. Passing through pole. What about the third? This is third. What about third?
Sir, passing through center.
Yes, passing through center. But here, what we can say? Passing through center or along normal. Along normal. Clear? Go for quick reaction. If there is any confusion, immediately ask me. So this is what the figure is given in your textbook 59 page number, third figure. Right? Third figure. I used one more extra ray, that is through the optic center. It is also remains undeviate. Okay. Right? So now we'll go for another here. So now I'm taking the same concept, curved surface. One surface is a rarer medium, one surface is denser medium, identifying the pole, identifying the center of curvature, and connecting them with a line called principal axis, right? So now I'm using the different case. What is a ray incident parallel to the principal axis, right? How the ray is now? How the ray is now? This is parallel to principal axis, right? Parallel to principal axis. Then how this light ray behaves when it propagates from one medium to the another medium. That medium is what? Air to water, means what? Rarer to denser. Rarer to denser. Is it clear, everyone? Is it clear, everyone? Right. So here I'll ask you one thing. On which surface I targeted the light ray? Which surface that light ray is going to meet?
Convex surface.
On convex surface. Very good. So here light ray is targeted on the convex surface, but I am not giving importance to the surface. No importance. Just I am depending on one observation, that what I experienced when I insert the pencil into the glass of water. It is bending towards the normal or away from the normal. That I will use. So here, when a light ray propagates from rarer medium to the denser medium, I have knowledge or I experienced that is bending towards the normal. So I want normal here. So this line is what here? Normal. The line which is connecting the center of curvature and the point of incidence is called normal. So I have incident light ray and I have normal, and I know that a light ray propagating from which medium to the which medium. Can anybody name that light ray in which medium now before meeting the surface?
Sir, rarer to denser.
So it is in the rarer medium. After bending, that means after crossing this curved surface, right, it enters into the denser medium. So what happens when it enters into the denser medium? Will it remains in the same direction like this? Will it remains? Will it remains? Say yes or no. Will it go straight? No. Why? Because it is changed its medium. When it changes its medium, speed changes. Automatically, according to Fermat's principle, it deviates from its path, which take least time. So it never remains in that path. So what happens? It bends towards the normal because it is in the denser medium. So rarer to the denser medium, it bends towards the normal. Clear, everyone? Clear, everyone? So this is given as case 1 in your textbook. In your textbook, case 1. Figure number 4.8 is. Figure number 4.8. Are you following your textbook now? Just look at them and understand the meaning. I am not depending on the information given in the textbook. I am only depending on the practical experience with the pencil. Is it bending downward or upward when you see through it, through the water glass, right? Bending downward. So it is becoming closer to the normal. That knowledge I am used. Nothing else in this. Any confusion? Any confusion? Go for quick reaction. So in this case, what happened after refraction? That light ray coincides or meets the principal axis or not? Does it meet the principal axis? Yes, it is going to meet the principal axis in this case. Then I'm going to another case here now. The case is same. I changed the medium now. Can anybody, what the difference you felt up to the previous and now? Look at the previous one, fourth year figure. Now I'm using another one here. Look at it. Look at it. What the difference you are noticed? Is there any difference to the previous and now? The case I considered. So in the previous case, you have the denser medium towards the concave surface. Now I changed that medium, denser medium towards convex surface. Clear? Just I changed the medium. Right? Okay. So now I am identifying its pole. Where its center will be? In the denser medium or in the rarer medium? Anybody? Anyone from you? I want center of curvature for this curved surface. Where it will be? Is it in the rarer medium or in the denser medium?
Sir, rarer, sir.
In rarer medium.
What's right side or left side to the pole?
Right side.
Sir, right side.
Right side. So you can identify its center and name it as C. Then connect with a line passing through it. What we can call that line is? This line is what? Principal axis. That's it. Then here I am considering the same parallel light ray, right? That is now targeted from the denser medium into the rarer medium, right? So principal axis and the ray considered parallel to the principal axis. Is it that case or not? Right? Now the ray is parallel to the principal axis or not? Answer me fast. Yes, it is parallel to the principal axis. On which surface it is targeted? Convex surface. Yes, on convex surface. After crossing this surface, in which medium it is there and enters into which medium? Before that, it is in denser medium. After crossing the surface, entering into the rarer medium, right? So here to know the behavior of light ray and depending on the same experience, what is rarer to denser towards the normal, denser to rarer away from the normal. So I need normal. So connect the center of curvature and the point of incidence called as normal. Okay. Then what you know the behavior of light ray? Denser to the rarer. Towards or away?
Away.
Away. So here I have something gap between normal and the incident light ray called as or denoted as angle of incidence. When it is enters into the rarer medium, angle of refraction is becoming greater than angle of incidence or less than angle of incidence. Tell me. Which is greater, which is smaller? Speak out.
Angle of refraction is greater.
Very good. Angle of refraction will be greater. That means here the angle become greater than I, right? So the gap between the normal and the refracted ray increases or decreases?
Increases.
Yes. So we can draw a line by increasing the angle. Is it clear, everyone? Is it clear? Same knowledge I used. The light ray bends away from the normal if it is propagating from denser to the rarer, right? So I got the behavior of light ray, whatever it may be the surface, wherever it may be, but I'm using same point. bending toward the normal or away from the normal. That's it. Right? So this is given in the figure number 4B in your textbook. Then we'll go for another situation that is here, is like this. Right? Same thing. Right? Concave surface side, dense or medium. Right? Concave surface side, dense or medium. Now, connecting them, polarized principal axis. Now your light ray is like this. Opposite to the previous case. In figure number 3, what we are taking, figure number 4A, what we are taken meets that convex surface from rarer to denser, right? I'm not changing that medium, but the direction of light ray exactly opposite, denser to the rarer, meets the concave surface. So whatever it may be, what I know, light ray bends towards the normal, light ray bends away from the normal. That I know. So I'm using the same logic. So here, in which medium it is there? Light ray, parallel to the principal axis. In which medium? Rarer
Denser
or,
medium.
rarer or denser? In the medium called denser, water. Then it is propagating from denser to the rarer. So what changes you notice here? It bends towards or away from the normal. Denser to the rarer. Towards or away? Answer me first.
Away from the
Very good. Denser to the rarer, away from the normal. So where is normal? Connecting the center and the point of incidence. So just blindly measure or assume the angle of incidence. So when it is enter into the rarer medium, from denser to the rarer, angle of refraction will be greater than angle of incidence. So here it will be become more comparing with I. So this is R. So then what to do? Just you have to draw a refracted light ray with the normal, increasing the gap away from the normal. Is it clear now? How I drawn? I'm not measuring anything. Just blindly I am assuming that. Is it clear? So here automatically after refraction, it is coincides with the principal axis, meets the principal axis at a certain distance. Is it clear? This is given in the figure number 4C. Right? I'm not remembering that blindly after refraction, it meets the principal axis. I'm getting directly if I follow the logic, that is rarer to the denser towards the normal, denser to the rarer away from the normal. That simple logic helping me to understand or in drawing this behavior of light rays parallel to the principal axis. Are you clear? We make quick reaction. So any diagram you can draw by using this simple logic, bends towards or away. That's it. No need to think about, no need to by heart them. Right? So we'll go for another case. Right? That is here simply opposite to the previous. So I changed the medium again towards convex surface, identify its pole, right? Then identify its center of curvature, then join them with a line called principal axis, right? Here, now the light ray targeting from rarer to the denser medium and the ray is principal parallel to the principal axis. Then how it behaves, right? How it behaves. Then connect the center of curvature with the point of incidence called normal. Then here, assume the angle of incidence here, right? Then what happens? Rarer to the denser. If a light ray propagating from rarer medium to the denser medium, anybody? Rarer to
Sir,
the
it bent towards the.
when towards the normal means angle of refraction increases or decreases.
Decreases.
So becomes less than. Becomes less than. Angle or becomes less than. So it comes closer to the normal. So smaller angle, right? So connecting that. So is it going to meet the principal axis? Coincides with the principal axis after refraction? No, does not meet, right? Doesn't meet the principal axis here. So it bends away from the normal. It bends away from the normal. Is it clear? How I got all the 4 cases without reading, without by hearting, without getting any extra knowledge except that rarer to the denser, denser to the rarer, towards or away. Clear, everyone? If I ask you, can you draw? ఏదైనా draw చేయొచ్చా? If by just knowing the denser to rarer or rarer to denser. Simple. Right? Clear? So this is about behavior of light rays when it meets the curved surface or how they are bending. Right? Then after this, we have one more concept, that is observing the lemon in empty glass in a glass of water. Have you observed that a lemon in a glass of water and in an empty glass? Anybody answer me? Just respond. Unmute.
Yes, sir.
How do you feel when you observe a lemon in empty glass? Compare it with water. A lemon is placed in glass of water.
Sir, when we keep the lemon in the water, it will float. When
Yeah.
we keep in the.
What about the size of the lemon? Whatever it may be, it depends on the density of liquid. It may sink or float. Okay, right. So here simply, I am asking the size of the lemon in empty glass and in the glass of water.
Sir, in glass of water, it will big, sir. In empty glass, it will be normal.
Why it is observed as big, right? So when you see a lemon in a glass of water, it appears bigger. Yes or no? Yes. So here, why it is observed as bigger? So let us see here. I'm taking a table and I am arranging one glass, right? And asked my friend to observe the lemon, right? Then what we required, a lemon is required. So now I am dropping the lemon into the glass of what, in a empty glass, right? So I drop that into a empty glass. So here ask your friend about that size of the lemon. Just try to remember estimating the size blindly. Then now fill that with water. Just add water. What happened? See clearly. When I add water, observe the lemon on the screen in the glass. What happened to the lemon dropped in the empty glass, right? So here now I am adding water. Look at the size of the lemon. What happened?
Size increases.
Size increased. Why the size increases? Why the size increases? What happened? Is it appeared to you original lemon or its image? What you can view? What you can view? Right? So here, actually, you are observing the size of lemon is bigger. Size of lemon is bigger, right? So here, compare with original lemon here. Original lemon is in this size, and the lemon which is dropped in the water observed in this size, bigger, right? Here, actually, this is what you are viewing is called image. Sir, how it is image? In a empty glass, you have the lemon size is this one. You are receiving the light from that lemon towards your eye. Sorry, I'm unable to draw straight. So I'll use the templates. So this is what here I'm showing you with the red color is original lemon, right? When you view that through the glass of water, what happened here? Through empty glass, you are receiving the light ray directly towards your eye, right? From the top and bottom. But when it is added by the water, you are receiving the light ray from different spot, right? From different spot. That is what here, simply from here, right? But actually there is no lemon there. It is why happened because of refraction. Because of refraction. Sir, like that, how it can be refract? So I will show you. Here, actually, if there is no change in the medium, the light ray goes like this. Due to what? That here simply the original ray is a red line. I am showing you here normal at this spot. So at the normal, it is changing the medium here. So at that interface, what happens? Refracts. In which direction? Denser to the rarer. Denser to the rarer. Answer me. Light ray bends in which direction? Away from the normal. So here the angle of refraction increases. So here it bends away from the normal, that light ray you are receiving. So your eye cannot realize this ray. So what it can estimate? It is coming from this spot. So your eye can estimate the size of lemon eyes like this because of that bending light ray. Is it clear, everyone? How that you can feel eyes bigger in size, right? So this is actually happened. Okay, so this is the reason for the getting of a bigger lemon in glass of water, observing the lemon in bigger size, right? So this meeting also coming to end now. Okay, individually give me your response about today's class. How you felt, Sri Charan?
Sir,
Is it okay?
sir, totally clear.
Okay.
Yes, sir.
Okay, just stay in the meeting. Surajita,
Sir.
clear everything
Yes, sir.
or difficulty in understanding anything?
Sir, no.
Okay,
Understand.
Vikrant,
Sir.
clear everything?
Yes, sir. Clear.
Right. Vikrant, Surajita, Sri Charan completed. Abhinay,
Sir,
clear everything?
yes, sir, clear.
Right. Medhasri,
Sir.
clear everything?
Yes, sir. Clear.
Tejaswini,
Sir. Clear, sir.
okay, Kaushik, don't use your earphones.
Sir.
Clear everything?
Yes, sir.
Yeah. Can I take one more class in the evening time? Are you available to attend the class?
Yes, sir.
Sir.
Use your quick reaction.